I just hit record.
All right. Well, I'll get started. Oh, could you make me co-host?
Okay. So welcome everyone. Today I've got Aaron Weiskittel from University of Maine. He's presenting on his new CMS project as part of hoping to be sort of a on again, off again series of informal talks by working group members just to talk in a little more depth and detail about their own projects they're doing, and then we can look for overlap and synergies with our own work and help each other forward. So Aaron, I can see your screen. You're welcome to take it away.
Well, thanks, Andy, and excited to be part of this working group. As Andy mentioned, we're one of the recent cohorts of CMS projects led by Dan Hayes with two other research faculty, Aaron Simons-Lagarde and Casey Lagarde. As Andy indicated, this is a University of Maine effort. It took us 3 tries, but we're excited to be part of the CMS group and open to some feedback. We just got the funding last month, so not much has happened in terms of the project, but I did want to provide an overview of it and then also talk about the FIA Biomass project, which probably has broader implications for all of the CMS projects that are dealing with forest data. Again, I oversee the Center for Research on Sustainable Forest. Dan Hayes sees the Wheatland Geospatial Lab. Aaron and Casey are part of an Intelligent Geosolutions initiative that we've started within the center. And then our key stakeholders, basically representing about 10 million acres of Maine's forest, is through the Cooperative Forestry Research Unit, which is a university industry cooperation. Bruce Cook is a scientist at Goddard, who just, successfully launched Landsat 9. Also, we have partners with the U.S. Forest Service, Chris Woodall of the Forest Inventory Analysis, and then Karen Diamond of the British Columbia has worked on some of the tools that we'll use. Just a reminder, if people have not made it to Maine, most of the time you need an excuse to get here, kind of the end of the U.S. But forest and kind of climate are go together in Maine. We have 7 distinct climatic zones, basically dealing with elevation and proximity to the coast. We're also a transitional ecosystem in that we go from the temperate deciduous hardwood forest of the south to the more conifer-dominated boreal forest, and that has varied over time. Another unique part of Maine is that we have a very diverse ownership. We're about 95% privately owned by over 100 different organizations, which includes a lot of non-industrial private forest landowners, which are about half the composition, but the other half of the state is REIT, TMOs, NGOs like TNC and Appalachian Mountain Club, as well as state and other private owners. It's about a 7 million hectare forest that's pretty diverse and has about 15 to 20 commercial species. Over the last decade, I've worked closely with Aaron Simons and Casey Lagarde. Aaron is a landscape modeler. Casey is your more classic remote sensing type, and I'm actually neither, but I think it's important work that we're highlighting the effect of harvesting natural disturbance in succession for about a 4 million hectare chunk in northern Maine at a 30-meter resolution. We just had this recent publication coming out, kind of highlighting our efforts of using Landis that's both relying on remote sensing data for calibration and evaluation. In our CMS project, what we outlined was to do a backwards calibration of Landis model. So to do that, we would generate a Landsat time series over the last 3 or 4 decades, initialize the model at the beginning of that series, see where it ended up currently, and then fine tune the parameters so that we kind of matched the predictions. And from that, we could derive some model uncertainty. Once we had the model calibrated, then we could do relevant scenarios to our stakeholders here in Maine to look at forward spatial forecasting, basically over the next 50 years, with different types of forest carbon management efforts. If you might know, an earlier CMS project was led by Warren Cohen and others in 2013. They established several intensive field sites throughout the United States, which were used for disturbance monitoring and just kind of general calibration. One of those sites is a Landsat scene up in northern Maine that coincides quite closely with the study area that I mentioned. This is a working parcel. It's gotten several G-Lite acquisitions, and it has a range of ground-based data there. I'll zoom into it a little bit. So here you can see the flight lines that Bruce Cook has used. So we just finished up our third acquisition on these lines just a few weeks ago, and Bruce has sent along the data. So there's been G-Lite flown on this in 2015, 2017, and now 2021. Based on the histogram below, this is very typical of Maine's forest, a range of above ground carbon estimates, with most being around the 50 to 100 range, just because of the management and the previous history that goes on there. Next summer, as part of our CMS project, we plan to remeasure these 100 CMS plots to give us some estimates of dynamics and future change. Dan Hayes has been able to work with the recent G-Lite data that we've collected. This is very typical of the patterns that we see, which makes kind of relying on other sensors like MODIS and Landsat difficult. As you can see, most of the harvesting that happens in Maine, probably about 98%, is mostly these partial harvest that vary in size and intensity. So here we're looking at basically a canopy height in 2017 and the prior LiDAR acquisition in 2012, and highlighting the change in the forest canopy, which shows kind of that fine scale level of management at very 5 to 10 meter pixel sizes, which is important for our model calibration, as also our model initialization, as it relies on good input data. But you can see the G-Lite data is very good at detecting those fine scale changes, which we hope to connect to Landsat and JEDI as well. And this is one of the few areas that we think we have very high resolution repeat G-Lite data, which I know Bruce Cook is quite excited about. And again, as I highlighted, we're going to take a multi-sensor approach to basically initialize and calibrate Landis, the ecological model that's doing the forecasting. We'll do both hindcasting for calibration and evaluation, and then forecasting to look at the future kind of baseline rates and different management or natural disturbance regime. A big one on our minds right now is spruce budworm, which is currently impacting about 20 million hectares up in Quebec and New Brunswick. A very large and devastating insect that can quickly change forest, and has been slowly moving south over the last 5 years. But as stakeholder engagement and participation is important with these CMS projects, we have created an online GIS platform, which we've called Forest, for forest estimation status and trends. You can find the web link there on the right. Basically right now we have, for the 4 million hectares that we've been working with, we kind of have their budworm risk and then other measures of biodiversity like Canadian lynx probability, to help managers think about which areas they should be targeting for budworm protection or salvage, and then try to kind of combine that with conservation goals. Through the CMS project, what we're hoping to release is a statewide carbon and forest type map, which should be done in early 2022. And then we're also going to host our Landsat, our Landis hindcast and forecast on this website, so users can really get a good feel for how things have looked in the past in terms of carbon and how things look currently, as well as understand the trajectory of carbon under different scenarios, like a potential budworm outbreak. So we're excited about that because it kind of creates a dynamic dialogue with managers and other organizations within Maine, and is a good way to kind of transfer the data that we are generating through this CMS project. To get back to an earlier conversation, I think at our first meeting of this kind of working group, I mentioned an ongoing project with the U.S. Forest Service Forest Inventory Analysis Group. This is a 10-year collaborative partnership with the U.S. Forest Service, as well as Nakazi and several other universities across the United States. Basically, the FIA recognizes some of the limitations that they are currently using to estimate biomass and carbon, and wanted to make sure to fully vet and develop a potentially new system for doing that. In 2015, we wrote a paper in Journal of Forestry that really emphasized the importance and the value of improving biomass estimation for a variety of applications. We just basically collected, so we went out and collect data as well as harmonized existing biomass data sets. Each of the universities was tasked with coming up with their own protocols. One of the winning protocols was from Virginia Tech, based on some input from the University of Maine. The idea was to move away from using regional or kind of state-based estimators, which can create deficiencies. Andy probably could talk about that. As you go from Idaho to Washington, certain things in the FIA database change just because you cross regional boundaries. So what we emphasized instead was the reliance on an ecoregion approach. So on the left here, I've kind of highlighted the EPA or the USDA's ecoregions level 2, which are now using to inform the biomass estimation, which is still done at a species specific level. On the right there, I've kind of showed the one-to-one line between CRM1, which is currently what FIA is using, and CRM2, which is our revised, which will be implemented probably early in 2022. Here I'm showing casting the differences across the different FIA regions, as well as the overall trends in the upper left. If you look at it, there's pretty good agreements between the two approaches, but there are subtle differences. And those subtle differences are important when you start scaling across millions of acres. So instead here, what I've summarized is basically the state level percent differences between the current CRM, CRM1, and CRM2, as well as giving you a histogram of those differences. In general, what we found, the CRM1 generally underestimates total above ground biomass, particularly for the stem, as well as things like branches and foliage. Whereas our method is a bit higher, depending on where you are. The late stakes in particular were quite dramatically being underestimated by CRM1. So they'll see changes in their state level inventories about 20 to 30%. Some states like Indiana and Illinois might be up to 30 or 35%. So pretty dramatic changes. Out west, not as dramatic changes, maybe 5 to 10%, depending on where you are. And then also in New England, we'll probably see changes around the 10 to 15% region. Overall, this is about a 12% increase in the total above ground carbon or biomass for the continental US as we go from one of those methods to another. So important to think about that there should be pretty significant changes depending on which calibration data you are using from FIA, and just being able to match that with the other online or the other FIA estimates. So with that, I would welcome any comments or input based on that. So hopefully that covered what we were seeking, Andy, and happy to take any questions.
Yes, thank you, Aaron. And I'm glad you also touched on your the CRM modeling work you're doing at a national scale, because that's also of interest to our group. I was jotting down a couple of things I wanted to ask you about, and maybe I'll kind of go backwards because you just talked about CRM. And of course, see, I'm working in the West, and so I'm interested that the difference, the increase was, you thought only 5 to 10% in the West. It seems like it's really concentrated in the Midwest. Is this anything to do with coniferous and deciduous forest cover, or what do you think is behind that?
Yeah, I don't think there's anything ecological to interpret here. Again, if you look at these really closely, they align with the FIA regions to some degree. Really what was happening was each region was using different volume or biomass equations, and the ones in the lake states were not particularly good. at estimating volume or the crown biomass. Whereas in the West, a lot of the underlying volume and biomass data actually came from Douglas fir or ponderosa pine. Same with the Southeast, a lot of it came from loblolly pine. It's probably the two tree species that we have the most observations for. So in general, the regional volume equations were doing quite well there, and there wasn't much change in that. There is, and I was going to produce a county level estimate. As you can see that though in the inland West and the West, there are a bit of these ecological divisions, and you can see subtle changes as you go from west side Douglas fir to east side Douglas fir that they kind of get washed out when you look at it at a state level scale, but there will be now kind of, I would say, more consistent trends at the sub-state level, particularly county or at the eco region level.
Yeah. Before I ask another question, I just want to welcome Kevin here. And Kevin, can you have your camera on?
Okay, can you hear me?
Yes.
Okay, let me.
I think I might stop recording. Is that okay with you, Aaron?
Okay.